All right, let's talk now about solving quadratic trig equations. Quadratic trig equations are quadratic because they have a degree of 2. Something is being squared and we need to solve. When we are solving quadratic trig equations, it's sort of like we're solving quadratic equations. It's just that they have the trig functions built within. And so when we need to solve these functions, what is actually going to happen is we're going to be needing to factor in order to find, like, quote unquote, the x-intercepts. Sometimes that's sort of a tricky concept, and so one of the strategies that I'm going to introduce you to that you can use and continue to use, and maybe one day you'll be like, oh, I can just do it in my head, or maybe you're going to continue to use it, is totally fine. What's going to happen is we're going to substitute x for the trig function, and then we're going to put it back in afterwards. So I'm going to show you what that looks like in our first problem here. So we're being asked to solve sine squared theta plus sine theta is equal to 0. So what I'm going to do off to the side here is I'm like, I've got no idea what's going on. The function that I have, though, is sine. And so instead of sine of theta, I'm going to write x. Okay, so let's rewrite this question now as if it is x. Sine squared theta, remember that's just sine theta squared. We just put the square on the inside. So that's like saying x squared plus x is 0. Well, that's easy. We know how to factor this. We can common factor this. I can factor out an x, and then I have an x plus 1 is equal to 0. And my muscle memory, my quadratics takes over, and I'm like, well, there's two possible answers here. Possible answer number 1 is that x is equal to 0. Possible number 2 is that x is equal to -1. That's coming right from here. But the question wasn't asking for x. The question was asking for sine of theta. Sine of theta is what we put in for x, is what we said x would be equal to. So let's put it back in. Sine of theta is equal to 0. Sine of theta is equal to -1. Huh. Okay then. Now we're dealing with problems. So when is sine of theta equal to 0? Well, that's sure not one of the special triangles. None of the special triangles had a 0 in it. So let's take a look at our sine function. I'm just going to do a quick sketch here. We recall that the sine function starts at 0. It goes up. It hits the x-axis at pi, I should say. And then it comes back around, it hits it again. That's a little bit too loopy. Here we go. At 2 pi. This moment is pi over 2, and this moment is 3 pi over 2. Oh, okay then. So when is sine of theta equal to 0? Well, it's equal to 0 anytime it hits the x-axis. So it's 0, pi, 2 pi. That's pretty sweet. Now, we do have a restriction on our answer here. We're actually looking for on the interval between -pi and +pi. So I'm going to extend my loop backwards 1, and this will be -pi. And so my actual answer here for my first one is going to be at the -pi, at 0, and at +pi. So in this case, theta will be equal to -pi, 0, +pi. I'm going to use the same diagram for my second option. The second option here is when is sine of theta equal to -1? And when is it equal to -1 between -pi and +pi? Well, right here. And where is that happening? That's happening at -pi over 2. So theta in this case will be equal to -pi over 2. We're going to bring all these answers together. We're going to say, therefore, theta will be equal to -pi, -pi over 2, 0, and pi. And I just put them in ascending order. Okay? So to recap here, we used a factoring strategy, but before we even did that, we substituted our function, in this case sine, we put it as x. And then we factored our equation as if it was x, and then we went back and we put the sign back in, and then we solved. In this case, there were no special triangles. We just simply needed to use our knowledge of the sine function in order to get our answer. Woohoo! Okay, let's do another example here. Solve 2 cosine squared of theta minus cosine of theta minus 1 is equal to 0, and it looks like we're back on a normal interval between 0 and 2 pi. Okay, which function am I dealing with here? I'm dealing with cosine, so I'm going to let cosine of theta equal to x and rewrite this equation in terms of x. My new equation will be 2x squared minus x minus 1. Okay, I'm going to use decomposition to factor this, but you can factor it in a lot of different ways. I'm looking for two numbers that add to -1 and multiply to -2. My answers there are -2 and +1. So I break up my middle term into -2x plus x minus 1. And then I common factor out my first two terms. 2x will leave me with x minus 1, and then I just have an x minus 1. I finish off my factoring by grouping 2x plus 1 times x minus 1. Okay, and we know that all of this is equal to 0. So now I've got my two options. I've got option number 1 is that 2x plus 1 is equal to 0. And I've got my option number 2, which is that x minus 1 is equal to 0. But the question never was about x. The question was about cosine. So let's put cosine back in here. Tap him back in. 2 cosine theta plus 1 is equal to 0. Cosine of theta minus 1 is equal to 0. Okay, let's solve. I'm going to rearrange my first one here. 2 cosine of theta will be -1. Cosine of theta will be -1 over 2. Okay, let's check. Let's see, is this in either of our special triangles? In my pi by 4 triangle, I have a 2, but it's underneath the square root, so it's not the pi by 4 triangle. I wonder if it is the pi by 3 triangle. Let's see if this works. I'll do pi over 3 up here, so this side is root 3. Pi over 6 here. I don't know what. I don't want ruler. There we go. Oh gosh. Okay, let's try this again. Quick cut. Okay, let's check to see if this is in any of our special triangles. I know it's not in the pi by 4 special triangle because although it has a 1 and a 2, the 2 is underneath a square root, so that's not going to work. Let's see if our other special triangle is going to work. Our pi over 3, and this side will be root 3. Pi over 6, 1, and then this guy is 2. Okay, if I know 2 is my hypotenuse and -1 must be my adjacent, so in that case, my theta must be pi over 3. But that's my related acute angle. Look, cosine is a negative here. And so which quadrant is cosine negative in? Let's figure it out. I use my cast rule. And I can see that cosine should be negative in quadrant 2 and in quadrant 3. So my related acute angle is going to be pi over 3, but it's going to be in those two quadrants. So I'm going to have one like this and another one like this. This will be pi over 3, and this will be pi over 3. We need to figure out what the actual location is of these two angles coming from the positive x-axis. So let's do that. My first one is going to be this angle. So I'm going to figure that out by saying, well, what does pi take away pi over 3? And that's just 2 pi over 3. My second angle, I have to go around further in order to get there. And this time I'm starting at pi, but I'm adding pi over 3. And so my actual angle will be 4 pi over 3. Okay, so those are our two options here for theta. For this factor, recall that we actually had two factors that could have been equal to 0. Our first one has produced two results, and we are respecting our restrictions. Remember, the restrictions said anything between 0 and 2 pi, so we're good. Now let's take a look at our second one here. So our second one was cosine theta of -1 is equal to 0. I rearrange that to be cosine of theta is 1. This is not a special triangle, so I'm going to refer back to the graph of cosine in order to figure out where that is true. And I'm just going to sketch cosine really quickly on 0 to 2 pi. This will be 2 pi. This is pi, pi over 2, 3 pi over 2. Okay, I have a 1 and a -1 down here. And I need to know, when does my function equal to 1? Well, it equals to 1 at 0, right there, and at 2 pi. So we've got two options here. It could be a 0, it could be a 2 pi, and we're going to merge them with the options from the first factor. So I'm going to write a nice concluding statement in a new color. I'm going to say, therefore, theta could be equal to 0, 2 pi over 3, 4 pi over 3, or 2 pi. Lots of different options there. There's 4 solutions in total. Okay, let's do one last example here. Again, where we need to factor. We are asked to solve 4 sine squared theta minus 3 is equal to 0, and we're on a weird interval. We're on the interval -pi to pi. So we got to keep that in mind as we find our solutions here. Okay. I'm looking at this and I'm thinking to myself, could substituting in x, is that going to make it easier for me to solve? Is there a way that I can factor this? And the answer is no. Like if I were to say, well, 4x squared minus 3 is equal to 0, there's no factoring that's happening here. It's just rearranging. So I'm actually not going to factor with this question. I'm going to rearrange with this question. And I can leave my sine squared theta there for the rearranging process. My first step, I've just moved 3 to the other side, and now I'm going to divide both sides by 4 to give me 3 over 4. Now I need to get rid of the squared, so I'm going to take the square root of both sides, leaving me with sine theta is equal to positive or negative root 3 over root 4. Oh, and look there. Root 4 is 2. Aha, so this is looking very promising that we're going to have, we're going to be able to use our special triangles in order to solve. So there's two options here. Once again, our first option is that sine of theta is equal to positive root 3 over 2. And our second option is that sine of theta will be equal to negative root 3 over 2. Okay, and I'm getting that from the plus minus that's happening here. I'm just going to draw a quick sketch up here. Actually, let's start by referring to our special triangles and see which one are we dealing with here. Let's draw a better version of that. There we go. This will be pi over 3 root 3, pi over 6, 1, 2. And I'm dealing with sine, so my angle is going to be root or pi over 3, so that the opposite can be root 3. Okay, my related acute angle is pi over 3. Let's do our first one here. So our first question is saying sine of theta is positive root 3 over 2. And so according to the cast rule, I am working in quadrants 1 and quadrants 2. In quadrant 1, my related acute angle is pi over 3, just like in quadrant 2. Now, as a matter of fact, I can jump right to my second angle here. My first one works. Pi over 3, that's already this most simplified. It's starting from the positive x-axis. In order to find my second option here, I'm going to go, what's pi? Take away pi over 3. And that's 2 pi over 3. So one option is that theta is pi over 3. And the other option is that theta is 2 pi over 3 for this factor. Okay. Now, what's interesting here is we've basically got the exact same problem for our second factor. It's just that we have been asked to find when it's negative. And so where is it negative? It's negative in quadrant 4 and in quadrant 3. Same related acute angle. It's still pi over 3. It's just this time I want it to actually be negative. And so what are the two options there? Well, the first option that we come around is going to be pi plus pi over 3, which is going to be 4 pi over 3. And then our second option is going to go all the way around here. And to make that easy on myself, I'm just going to go, what's 2 pi take away pi over 3? That's like 6 pi over 3, take away pi over 3, which is 5 pi over 3. 4 different options here. I'm going to conclude with the therefore statement. Therefore, theta could be equal to pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Okay? So in this third example here, we did not factor. We didn't need to factor. All we really needed to do was rearrange and isolate our variable. And the moment we did that, we were able to identify that we were using and working with special triangles, which gave us the exact answer. Okay, and that's it for today. Great work, everybody.